So to start our lesson, we're going to be reviewing the foundations of basic arithmetic. So, can you guys tell me what that is? What's the answer to that problem?
5?
Yeah. Right. It's simple, just adding. Tell me the answer to this problem?
1.
1, right. Simple subtraction problem. Okay. This is a multiplication. Can you tell me what the answer to this problem is?
6.
Yeah. Okay. So just simple arithmetic. Adding, subtracting, multiplying.
What about dividing?
We're going to cover that later. So, we're going to be using these basic fundamentals in arithmetic. Chuck is not strong. With polynomial expressions.
Went from
Adding, subtracting, multiplying is going to be our lesson today with polynomials. You guys know what a polynomial is?
Yeah.
It looks like this. It has variable terms with exponents in descending order from greatest to least.
PEMDAS.
Yes, I was actually just about to cover that real quick. So just a quick review. Remember what this is? Parentheses. Hope you can read my writing. Exponents. Multiply. Divide. Add. Subtract. Okay. This is the order that you're going to complete operations in. So if you have a problem like this, you would do the multiplication first because it comes before subtraction. Right?
Yes.
You know the answer to that?
5.
Yes, good job. Proud of you. Okay.
I'm good at English.
Okay. So, on to our lesson. We're going to do addition first. So, we have these two terms. These are our polynomials. So what we're going to do with this, we're going to take the basic principles we learned in first grade, like the 3 plus 2 problem, and we're going to apply it to this. So what you do is you add the two polynomials. You're going to combine the terms that are similar, the like terms, which means that you're going to take terms that have the same exponent. Like if there was an x squared in this part, you would add them together. There's not, so it's simply x squared. There's only one x term being added in both of these polynomials, so that stays the same. The two like terms, the constants that don't have an exponent or a variable, 3 and 7, add together to get
10.
yes. So this is your answer. Simple adding?
Then x to the 3rd? Because it's an x.
No, because you're adding and not multiplying. If you were multiplying these, it would be x times x times x, x to the 3rd. But because these have different exponents, you can't combine them when you're adding.
Okay.
You think of multiplication, which we'll get to in a minute. Okay, makes sense? Any questions?
I asked mine.
Okay. Okay. So the next one was, we did 3 minus 2 in the beginning, right? So we're going to take these same two terms and we're going to subtract them this time. So it's the same principle, taking this term, subtracting it from that. We're going to do the same thing over here. And we're going to be doing combining like terms again. You only have one term with a squared exponent with the 2. You only have one term with no exponent, and you have these 2 that are the constants that don't have variables. So we're going to take this negative because it's getting applied to the whole polynomial and not just one term. We have to distribute it to each of the terms in the polynomial. So this becomes x squared plus 3 minus x minus 7 equals. And so now you just combine the like terms. X squared minus x. 3 minus 7. Minus 4. Any questions on that? Okay. So we have one more that we're going to cover today. Remember in the beginning we did 3 times 2, and that equals 6. This is going to be the most complicated out of all of them, but we'll get to it. So we're going to take these same terms, x squared plus 3, multiplied by x plus 7. Okay. So the process we're going to use to multiply these is referred to as foiling. It is an anagram, stands for first, outer, inner, last. So the process you're going to do is you're going to take the first terms in the 2 polynomials and multiply them together. You're going to take the outer terms, multiply them together, take the inner terms, multiply them together, and you're going to take the last terms in each polynomial, multiply them together, and then you combine all the like terms that you can, simplify it down, and get your answer.
X to the 3rd, right? So
Yes. Now you're going to get x to the 3rd. When you multiply these terms, x to the 3rd, then you're going to multiply the outer terms, 7x squared, multiply the inner terms,
3x.
multiply the last terms.
21.
Perfect. So is there any like terms that you see in this?
No.
No, there isn't. So this is the simplified form, and that is your answer to this problem. So remember, first, outer, inner, last. Just multiply it through. If you have any like terms, add them together, combine them, simplify it. You have your answer. Okay. So we did adding, subtracting, and multiplying. Using what? Okay. Any questions? Okay, cool. So I'm going to hand out a practice sheet for you guys to do. You work individually or together on it, and it is should be completed by the end of class. Anything you don't complete is for homework, yes.
I need a pencil.
Here you
I prefer a pen.
go. Oh, we get pencils. Anything else? Any questions?
Nope.
Awesome. Good job.
Where's the worksheet?